Hi everyone, this is Miss Afric here, and today we're going to keep solving, but we're going to solve a slightly different kind of equation, and that's a radical equation. Alright, so we're going to solve equations with radicals and continue to check for extraneous solutions. Alright, now when we solve radical equations, we're going to try and keep it pretty similar to how we solved rational exponent equations. But in order to do that, we have to make sure we know how to go back and forth between radical form and exponent form. So let's practice a little bit of that first. Alright, letter A, so we're going to rewrite the following from radical form to rational exponent form. So, for letter A, the third root of just 10. So remember, in order to write it as a rational exponent, you need to know the exponent and the root. So I can see my root is 3, but I don't have an exponent here. So do you remember what the exponent is? That's right, just a 1. So if I wanted to rewrite this, my base, the part inside, is still the part, is kind of the part in parentheses if you want to think of it. And then my exponent becomes 1 divided by 3. Root on the bottom, exponent on the top. Alright, for letter B, same thing, the fifth root of 5x. So again, the root is 5, and there's no exponent here, so that means the whole thing is to the first. So to rewrite it, that whole 5x, since it's all underneath, is getting the exponent of 1 divided by 5. Alright, last one, letter C, the square root of x plus 8. So, when it's a square root, remember the root is a 2. And once again, when there's no exponent, it's a 1. So if I wanted to rewrite this, I would put x plus 8 in parentheses here. And then it would be 1 divided by 2. Exponent divided by root. Alright, so like I said before, since we already know how to solve equations with rational exponents, it makes sense to just keep using that method through and through. So we're going to rewrite any equation with a radical to instead have a rational exponent. That way we can solve using the reciprocal exponent just like we've been doing. Alright, so let's try a few. Solve, check for extraneous solutions. So for number 1, I have the cubed root of 5x plus 10 equals 5. So just like we were doing before, I'm going to rewrite this radical to be a rational exponent. So my root is a 3, and my exponent is a 1. So that's going to be the whole 5x plus 10 in parentheses to the 1/3. Alright, and then we would just solve normally. And once again, when we solve equations, no matter what kind, we use reverse Pemdas. Alright, so in this problem, everything inside, these are all inside the parentheses, so that's the last thing I do, which means the only thing to do here, first at least, is to get rid of our exponent. So just like we did in the last section, to get rid of an exponent when it's a fraction, we're just going to raise it to the reciprocal on both sides. Alright, and just like before, you should still be paying attention to that bottom number to see whether it's even or odd. Alright, in this case that's an odd root, so there's nothing to worry about. We don't have to put a plus or minus. Alright, so over here, 1/3 times 3 over 1 cancels out, just gives us 1, so 5x plus 10. And then in our calculator we can do 5 to the 3 over 1. That's really just 5 to the 3rd, which is 125. And now I can solve normally from here. Alright, subtract 10 from both sides, and we get 5x equals 115. And then divide both sides by 5. So my final answer here is 115 divided by 5. Let's double check that real quick. Alright, ends up with x equals 23. And remember what it said in the directions. Same as with rational exponent equations, because that's really what this has become. We do have to check for our extraneous solutions. So make sure we remember to check. And we're just going to use our calculator to help us with that. Alright, so the cubed root of 5x plus 10. Remember where cubed root is? It's under math, and then number 4. And in there we've got 5 parentheses 23 plus 10, so 5 times 23 plus 10. And we end up with 5, so it checks out. Alright, number 2, same idea. So I'm going to rewrite this root to be a rational exponent. So instead of the square root of x plus 8, square root means the root's 2, my exponent is a 1, so this becomes x plus 8 to the 1/2. Alright, and then the rest of my equation. And now I'll continue solving just like we were before. So reverse Pemdas. That means I'm going to get rid of this minus 3 by adding it. So I have x plus 8 to the 1/2 equals 2 plus 3, which is 5. And now there's nothing else to get rid of except the exponent and then inside the parentheses. So to get rid of my exponent, once again, we're going to raise both sides to the reciprocal exponent. Alright, still checking for that even or odd root. And I know some of us might have figured out that for radical equations, we're always going to have an odd root because we've never had an exponent, right? But in the future, these are all going to be mixed up together. So it's important that every single time we have a rational exponent, we check to see if it's an odd or even root. Right? And in this case, it is once again an odd root, so no plus or minus. So we end up with just x plus 8 on the left. And then 5 to the 2/1, that's just 5 squared, which is 25. Alright, finish solving from there, subtract that 8, and we've got x equals 17, and there's my answer. Alright, once again, I'm just going to go quickly and check it, and we're going to use our calculator. So this time we have just a square root of 17 plus 8. Be careful how you type it in, right? Because if we type it in incorrectly, it could tell us that it's not right, even though it should be. So be careful. Alright, we end up with 2, which is what we wanted, so it checks out. Alright, number 3. This one gets a little trickier. We got to kind of bring back some ideas from last semester. So let's see how we can do. We have x plus 2 equals the square root of 9x. So once again, I'm going to look for my radical, and I'm going to rewrite it. So the square root of 9x, I put 9x in parentheses, and that'll become a 1/2. Again, because the root is a 2, and if there's no exponent, it's a 1. Alright, now for this part, we just have to be kind of aware of how these work. Alright, to get rid of a 1/2 exponent, I raise it to the 2/1, the reciprocal. So that'll just leave me with a 9x over here. And I have to do it on the other side too. Alright, now here's where we just have to think a little bit. Alright, x plus 2 to the 2/1, that's the same thing as saying x plus 2 squared, because 2 divided by 1 is just 2. And remember how many times we talked about this, so we really got to make sure we remember. X plus 2 squared, we need to actually distribute out. So I would have to rewrite that as x plus 2 times x plus 2 if I wanted to simplify it. And in this case, we have to simplify it because there's another x in the problem. And when there's multiple x's, you have to simplify everything completely in order to figure out where to go. Alright, so I'm going to go ahead and distribute this out. X times x is x squared. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4. So we end up with x squared plus 4x plus 4. And on the other side, still just the 9x. Alright, now this is the part where we have to go back and think about last semester. Alright, do we remember what this kind of equation is called when there's an x squared as our biggest exponent? That's right, this is a quadratic. Alright, and in order to solve a quadratic equation, it's not quite as simple as a linear equation. So what we're going to be doing is whenever we have a quadratic, most likely we're going to be using factoring in order to solve. Alright, so make a note of that so that if you ever get a quadratic, you know to try to factor. Now, if factoring ever didn't work, you could use the quadratic formula. Alright, but definitely try factoring first because it'll be a lot simpler if that works. Alright, in order to factor, it needs to equal 0 first, so that's what I'm going to try and do here. So I'm going to subtract this 9x to both sides so that now it equals 0. And here now I have x squared minus 5x plus 4. So now that it equals 0, we can go ahead and factor, and that should allow me to solve. Alright, so I get x, minus 4, and x minus 1. Swing up here because I'm running out of room. So then I just set each factor equal to 0, and solve. So we end up with two answers, x equals 4, and x equals a positive 1. Now, especially when you get more than one answer, you really got to make sure that you're checking, just in case, because you never really know how these answers will work out. So I'm going to go ahead and check them on my calculator. Now, when we check these, we're going to plug it in for each x. Alright, so it would be, for example, 4 plus 2 equals the square root of 9 times 4. Alright, that's the first one we check. And so I'd use my calculator. Well, 4 plus 2, I know that's just 6, so I don't really need to use my calculator for that. In fact, some of this we might not need to, but we'll do it just in case. Square root of 9 times 4. Hey, that's also 6. So x equals 4 checks out. Let's double check the other one. 1 plus 2 equals the square root of 9 times 1. Well, 1 plus 2 is 3. And the square root of 9 times 1. Again, some of us got that no problem. Others maybe just double check, just to be sure. And that one's 3 also. So in this case, both these answers work out, and they are answers. We don't have to cross anything out. Done with that one. Alright, one last one. Let's see. Separate these. So, for number 4, we've got negative 2 times the 4th root of x minus 3 equals 4. So once again, the first thing I'm going to do is rewrite these into exponents. So the negative 2 is on the outside, so don't put that in with it. Alright, just the x minus 3 is in the parentheses, and since it's a 4th root with a 1 exponent, that'll be a 1/4 exponent. Alright, and now we go through and solve, so remember, get rid of multiplication and division first. Well, get rid of addition or subtraction first, but we don't have any of that except in the parentheses, and that's last. Alright, so that tells me, alright, I can move on to the multiplication. So I'm left with x minus 3 to the 1/4 equals negative 2. And now we can go ahead and raise both sides to the reciprocal. So once again, I think I forgot to do it in the last problem, but hopefully you were smart enough not to forget. Check to see if it's odd or even. Alright, odd root, no plus or minus, no worries. So we're left with x minus 3 on the left side, and then negative 2 to the 4th. Now remember, when you raise a negative number to an even exponent, that negative is going to go away. And if you're ever not sure, just type it in with parentheses. Alright, if you type it in without parentheses, it kind of defeats the purpose. So, negative 2 to the 4 divided by 1. It is a positive 16, just like we should have expected. And then finish solving by adding 3. And we end up with x equals 19. So now let's go ahead and check. Alright, so that means we're plugging in 19 for x. So that will be negative 2 times the 4th root of 19 minus 3. Does that equal 4? Well, let's use our calculator. Negative 2. 4th root's a little tricky. We're going to type the root in first, so 4, and then we go to math, but this time number 5, where the x root is. That's what we want. Alright, so that's a 4th root. And then instead of x, we have 19 minus 3. And we want this to equal 4 in order for this to work. So let's see. Negative 4. Is negative 4 the same thing as positive 4? I sure hope you said no to that. Alright, negative 4 does not equal positive 4. And that means that this can't possibly be an answer because it didn't work out. So if the only answer we got isn't an answer, what do we have to say? That's right, no solution. So I know it seems like, oh, only once in a while this happens, but the fact that it could happen means that you always have to check your answers. Because if you get an answer that ends up being extraneous and you still circle it, that's going to be wrong, and we don't want to do that. Alright, if you have any questions, make sure you write them down. Otherwise, we're going to practice a lot more in class. So get pumped for it. See ya.